Right, welcome everybody to today's lesson. Today we're going to be looking at day 2, but I'm just setting up just for the next 30 seconds and then we can start. I'm just setting up and just make sure that everything else is working fine before we start. All right, we can begin. I trust that we all have had a good week so far. It's only Tuesday if you're on this side of the world, and in some parts it's probably still Monday. My day has been okay. I've got a big change that's coming up tomorrow, so I'm a bit nervous and excited at the same time. This is a project that I've been working on for quite a bit, and I'll probably give an update on Thursday how that is going. So if you've just joined us, please just show us by putting a thumbs up if you're watching us on YouTube. So this week is basically the beginning of our 6-week Network Plus bootcamp. I have basically put the times on the screen. So that's Tuesdays and Thursdays, 9 p.m. AWST for those that are not aware. I'm just recapping that just one more time so that we are all on the same page. So you can be able to follow me through. If you've got any questions, send your emails to Tinei. I'm just going to put my email on the screen if you have any questions. So that's right. So that's the email address to send. So if you've got any questions, send your email or you can put it on the chat and I'll be able to answer the question as we go through the lesson. If your questions come outside of the class, then I'll probably attend to them when we basically meet before we start. All right, I like starting my classes by basically going through a recap of what we covered, in the last lesson. So I'll just switch my screen and right, then I can be able to, all right, so I'll just do a quick recap of what we covered last week. So last week we were looking at the fundamentals of networking, and we said the OSI is at the base of the fundamentals of networking, and we defined the OSI as a reference model that is used for different developers and systems that need to interact and talk to each other on a network. The best example that we gave was the floor plan or the building drawing that everyone else basically uses as a reference model. And we basically summarized and said that the OSI was brought into play because in the 1970s, there was no uniform standard. Everyone was doing their own thing and basically building systems that worked in their own small vendor-specific environments. And the OSI basically allowed for different vendors to be able to then operate, interoperate, and work together. And we say that the OSI is basically defined into 7 layers, which is the application where we interact with applications such as HTTP, FTP, SMTP, all the email applications basically operate on the application layer. And we say as traffic went through, it would then get encapsulated. We spoke about the presentation, which focuses on encryption, decryption, and presentation of data. Session, we said it establishes the session, and then we went into the transport layer where depending on the nature of the protocol in question, whether TCP or UDP, different encapsulations then work. And TCP being a more connection-oriented application would then verify and make sure that information is being transmitted and require acknowledgements. We looked at what we call the 3-way handshake, which is what TCP uses to establish communication before any packets gets transmitted. And we say that TCP hands over to the network layer where we have IP addressing, and we're going to look at IP addressing quite extensively as we go into the next lesson. Yes, next lesson is actually focused more on IP addressing. What is an IP address? Different types of IP addresses that we find, and things like subnetting. So I know many people struggle with that topic. So make sure you put a reminder for the class on Thursday, because you're going to be focusing specifically on that particular aspect. We then say that after the network layer, we then go to the data link layer. And this is where we have frames. And we spoke about something very important that happens at the data link layer, which is MAC addresses, right? MAC addresses. And then we then went to the physical layer where we deal with bits, ones and zeros. And one of the key aspects that I highlighted when I was talking about this whole concept of encapsulation, I said encapsulation is basically wrapping data and putting a header depending on which layer you're basically operating. And this was the diagram that we basically looked into when we dealt with encapsulation. And I said that the best way that you can probably envision encapsulation is when you send a package or when you receive a package from Amazon, you've got a label that's on top of the box, and then you've got the package that's inside. What's inside is the data. What's on top of the box is the header. And it is that header that then decides how the traffic gets, how the package makes it to its destination. And we say that the IP header is made out of the source address, destination address, head sum checker, total length, protocol, TTL. Similarly, with a package, it will have a sticker, and on that sticker, there's the person who sent, the destination where it's going, the barcode, and all the things that then go along the lines. So that is what we basically covered last week. And today, we're going to be looking at the different network types, right? We're still continuing with our concept of network fundamentals, but we're looking at the different network types that we basically find. There are so many, let me just make sure that I've got that. Okay. So there are different networks that we encounter, on a day-to-day basis. We have the local area network. We have the campus area network. We have the wireless LAN. We have the wide area network, and we have storage area network. Now, the question is, what is the difference between these different types of networks? What are the characteristics that we find with one or the other? And how do we make the definition of what is a LAN versus what is a campus area network? So by simple definition, when you're looking at a local area network, you're looking at a network that is within the same building. And that's what we define as a local area network. The building might have a single floor. It might have multiple stories. But usually when you're still confined in the same building, that is usually defined as a local area network. Now, for many people, we operate on local area networks, and that's what we spend most of our day working on. However, there's another type of network which the best that I can give is one that you find at a university, where you've got multiple buildings, but in the same area or campus area. And we call that a campus area network. And why is it called a campus area network? Because these networks tend to have what we deem in the networking world the three-tiered system, or either the collapsed core. I know I'm probably going ahead of what we have covered so far, but later on we'll basically look at the different models of networking. So when we're talking about a three-tier system, just make sure that my pen is here, is when you've got a core network and you've got the distribution, and then off the distribution, you've got access layer. So this is the distribution, this is the core, and then you've got your access layer switches. And then the collapsed core is when you've got a core, and then you've got access switches that are basically running through. So when we're dealing with a campus network, what is basically happening is that each building would have, its own core, distribution, and then access layers. And then another building also on the campus will have something similar. So that's what we define or call a campus network. So it's just a LAN that is more extended, but you're still within the same perimeter of the area of the particular campus in question. Let me just take just a second. I need to just take something off. There we go. Let me escape that. I just want to remove this, what's on the screen. Okay, cool. All right. So back to that. Okay, so we've looked at a campus area network. The next one is a wireless local area network. Now, once upon a time, networks were mainly cabled, but with the advent of wireless technology and how that has succeeded, organizations now have wireless access points, and they have wireless as a business grade network. So with the wireless network, it's simple. You got an access point. Many people in our homes at the moment, we run on wireless. So it's very easy to conceptualize. I'm connecting my laptop via wireless. So when you're talking about a wireless area network, all we are simply saying is, this is a building. Oh, sorry, I think that's a bit too thick. Let me just change that. Okay, that. Okay, that's still a bit thick. Let me just change my pen. Okay, I think we should be good now. Okay. All right, so let me erase that. So this is our building, and this is typically what you find in a corporate environment. You'll have a wireless line controller, we'll call it a WLC, and then you will have access points that will be sitting on the ceiling that are basically providing wireless coverage. And then you've got PCs that are connecting, via wireless to the respective. That's a typical wireless local area network. And then it then gets bridged onto your normal switches for connectivity. So when you're talking about wireless local area network, we're basically defining this type of network. And then later on in this particular course, we're going to be looking at the different wireless standards and technologies, 802.11a, 802.11b, G, N. What are those technologies? What do they do? What are the throughput speeds that are involved when you're basically dealing with them? So that's what we cover when we're looking at the wireless local area network. The next one is the famous wide area network. And when you're talking about wide area network, what we're basically referencing to is it's a network that goes beyond infrastructure that is owned by your own organization. And what I'm basically meaning is that the wide area network part, the infrastructure that operates on this particular space is usually owned by ISPs. So you're basically connecting your organization. You might have an MPLS service, or you might have ADSL, or you might have satellite. All these technologies are basically coming in to allow you to come out of your organization and talk to an organization on the other side of the country or the other side of the world. So what we then define as a wide area network is we've got an office in Perth, and then you've got an office in Sydney. And then you use the services of an ISP to connect the two networks so that they can then talk to each other. So you're going over a wide area network, right? The next similar one is a metropolitan area network, where you are still within the same city, but you've got branches that are in different areas in the same town. So when you're basically looking at wide area network, that's what we're basically referencing to. And then the last network type that you're going to look at is the storage area network. And this one basically just references to a network of storage systems or devices that then connect to the bigger network. So you'll have something like this, right? So you got your SAN storage, and then that storage then comes in and connects onto your switches, which then go into your server infrastructure, and you've got your storage area network. It's important, for us to have an understanding of these different types of networks and how they interact and impact us as we then go through our networking. Right, so I made a mention of Mpls earlier on, and Mpls is one technology that is used to connect branches. This is probably one of the most popular ones that you find on the market today. And the reason why Mpls is popular, I'm probably going to go through. But one of the key reasons why Mpls is popular is the fact that it has the capability of integrating multiple technologies to connect branches that are spread across different geographical locations. And what I'm basically referencing to when I'm saying that is, this is an office that is in Darwin, and this is a head office that is sitting in Sydney, and these guys have got a branch that is sitting in Perth. Now, these organizations want to communicate with each other and form one single network. Now, in order for them to do that, in the absence of technology such as Mpls and other technologies that we're going to talk about, what you needed to do was to dig a trench all the way from Perth, all the way to Sydney, and then dig another trench all the way from Darwin, going all the way to Sydney. Now, just to give you context, the distance between Perth and Sydney is over 3,000 kilometers. Right, so probably digging your own trench is probably not going to make much sense. So what internet service providers have basically done is they've done the task of digging the trenches and basically installing fiber from different locations. And then they created this cloud, right? And they use technology such as Mpls. So then when you want to connect your different branches across the country, what you then do is you go and pay these guys some money, and you say, I want to connect onto your Mpls network so that I can then link my branches. So what then happens is they will have something known as a POP, or point of presence, and that point of presence will be one in Darwin, there'll be another one in Perth, there'll be another one in Sydney. Right, so all you need to do is to find fiber cabling that then goes, let's say 10 kilometers from your office onto the nearest point of presence in order for you to then plug in and connect into the Mpls network. So the reason why Mpls is popular is because it accepts multiple technologies, right? So the Darwin office can connect via ADSL, the Perth office can connect via ADSL, or it can use cable, or can use satellite. It doesn't matter which technology you use to get into the Mpls network. As long as you're able to get in, they are able to then service and get you on board. So that's why Mpls is very popular. And for the purposes of this particular course, there are certain aspects that you need to know about Mpls. So the first one is something known as a CPE, which is a customer edge router. This is the router that sits on the customer site. And then the second one is what is known as a PE, which is the provider edge. And this is the router that peers or provides connectivity with the with the customer, right? And it is the entry point of getting into the Mpls network. Now, Mpls uses a technology that is known as packet label switching. And though it's not covered in Network Plus, so if you are focusing mainly on the certification, this is probably not going to be of much benefit, but I'm just going to explain what Mpls basically does. So the general routing process of networks on a wide area network is routing packets based on the destination IP address. So your packet, remember we spoke about the IP header. The IP header has got a source address, and then it's got a destination address. And it is the destination address that routers basically look at and decide how they're going to route traffic to go to a particular destination. Now, the challenge with routing using the destination address is that every router along the path has to stop, look at the packet, look at the destination, and decide which path is going to be best to take the packet to where it's supposed to be going. And that in its process basically slows things down, right? The reason why things like DHL have scanners on top of the package is so that when the packets are being sorted, when the boxes are being sorted, they just get scanned and they get forwarded, and not much time is wasted trying to figure out, what's inside and where it's basically going. So what Mpls basically does is it encapsulates the IP packet, and then it puts a label on the packet. And then throughout the entire network, the packet is going to be routed on the basis of the label. So this, I'll just suppose this is an Mpls router. So this router 1, 2, 3, and 4. Router 1 will have in its table that any labels with the number 2 or 1 need to be sent in this direction, and any labels with the number 3 or 1 need to be sent in this direction. So the moment it receives a packet, it looks at the packet label, and then based on that label, it's going to send the packet in one direction or the other. And that basically quickens the routing process as it basically traverses through the network. And that's one of the reasons why Mpls has become more the predominant one technology that organizations basically use at the moment to connect their branches that are located across different geographical areas. And in most of the organizations that I've worked, Mpls has become the predominant technology for connecting remote branches to the head office and getting that connectivity to be able to function. And the other aspect, so we spoke about the P, the provider edge, customer edge. There is also one that is known as a P router. And a P router is a router that is internal to the Mpls one that does not talk to the customer, or neither does it talk to the provider edge. So it's basically a router that is internal. And these terms are important for you to know because they are in the syllabus. So expect yourself to get a question in the exam on what is a P router versus a PE router versus a CPE router. The other terms that they use is LSR or ELSR to basically define the same thing. It's just routers that are either inside the cloud for Mpls or routers that are on the edge that allow other devices to be able to then talk through as they are traversing through. So that is what you need to know about Mpls. But it is a whole complex protocol that when you go and do CCNA, CCNP, there's a whole lot that you then cover and unpack on Mpls. So if you have interest in Mpls, just let me know. I'll probably take time to cover that, but that will be outside of these particular classes. So now we're getting to, I think, what many of us have dealt with or what we deal with on a day-to-day basis. Now, when you're defining networks, there are two ways to look at it, right? We have what we call client-server networks, and I think many of us have probably operated in this space. With a client-server network, this is when you have a server and you got PCs. And this server could be an email server. It could be a file server, or it could be a JCP server. So you got PCs on the network that are accessing resources on this particular server in question. And that's a client-server environment. The other type of network that was in existence, but not popular nowadays, is what is called a peer-to-peer network. And in a peer-to-peer environment, you've got basically PCs that are connected to each other, but there is no predominant server. What usually happens is that files get shared. So if This is the PC that we're accessing files. It becomes the server. These ones become the client. When we're accessing files on another PA, it becomes a server. Others become a client. So that's basically a peer-to-peer environment. And many of us, we're probably going to find ourselves in a client and server environment. So it's important to know, but not very critical, but just for you to then have an understanding. The part where I want to focus on is the way we view networks, right? So we've got the physical topology and we have the logical topology. And let me just erase that. Right. This was the first types of networks that were built at the very beginning, right? It was a token ring. You used to have a token, which is more like a basket. If you wanted to communicate, you'd wait for this basket. You put your information in the basket, and then it goes in a circular motion, and then it transfers the packet. And then when it gets empty, someone else has the chance to be able to then send. And the challenge with this kind of network, whilst it was functional, was the fact that it was slow, right? Remember, you have to wait for someone to be able to transmit whilst you're waiting for the token to be able to come through. In a 3 PC network, not an issue. But when you start putting 50 computers that are trying to talk to each other, then you've got a crisis. So obviously it wasn't meeting demand. Let me see, I think I might just want to look at the chat and see if there are any questions or comments. Please, are these connections of the Mpls done logically? I'm trying to get, sorry, I'm just trying to answer this. I'll come back to this question, Ashiru, and I'll answer this question probably in the next 5 minutes so that I can give it much attention and I do not include other things in the process. But I'll come back to that question. Thank you for asking. Right, so I was back on the token ring. So the token ring had its own limitations and they needed to find a different okay, cool. They needed to find a different technology that would then allow much more efficient networks. The next standard was what was known as a bus. And this was when computers were connected on a single cable. And all you had to do was you had something known as a vampire clips. So you had the network cable passing through, and then you'd come and clamp on that cable, pierce the cable, and then get connectivity on the network. And when you looked at it from a high-level view, it symbolized more like a bus infrastructure. And bus topologies were pretty popular. I remember when I came into the network industry, they were right about the time when they're being phased out. And you used to have T connectors that would come in and allow you to then connect to your PC to the network. The challenge with the bus topology was the cable was a single point of failure. When this cable snapped at this particular point, the entire network had to stop. That was the first one. The second one was something known as collision CSMA/CD, where you had to listen to the wire to see if anyone else was sending, and you would then send your packets. But then if someone else was sending at the same time, the packets would then collide. And then you had to then wait for a period of time before you can then send your messages again because you're sharing the same bus. So that was the challenge with the bus topology. Then came the ring topology, which almost similar to the token ring. The only difference is this time around, you're not using a token. You are sending at the same time. But once again, traffic is flowing in one direction and there is that concept of collision and waiting for one another. So the one that is the most popular and being utilized today is the star topology. And if you were to work in any network environment, this is the topology that you're going to be using. And the star topology is basically made of by having a switch at the center of your network. And each computer connects to the network through a UTP cable. And the good thing with that is the fact that that cable is connected to one PC. So in the event that something happened to that cable, it does not affect anyone else, but except that one particular computer in question. And these switches come in different sizes, right? 8, 12, 16, 24 port, 48 port. And in a 48 port, it basically means that all the other 47 users are basically not affected. And that then became the most cost-effective way of connecting users on to the network. So the reason why we're covering these topologies is so that when you encounter a network in a work environment, you kind of have an understanding. When you see a switch or a hub device, you'll be like, aha, I know, I've studied about this network topology. This is how it works. These are the characteristics that are basically involved. And these are the speeds that you're basically going to be operating on. And that's the whole aspect of learning, of going through this particular course. It's so that you have an understanding of the technology and being able to apply it and use it when you basically look and work in a work environment. So these are the different topologies that you will encounter as you basically go through in the industry, right? So I'm just going to take a sip of water and then I'll come back to Ashiru's question on MPLS. All right, so if you've got any questions, please let me know in the chat. If not, you can send me an email. Email address is somewhere on the screen or in the description. You'll find the email address to be able to send your questions. All right, so coming back to Ashiru, so this is our MPLS network, right? And we've got organization 1 that has got an office in, we'll just call this Perth, and they're trying to talk to their head office that is sitting in office number 2, which is in Sydney. So what happens is that this company is then going to go to the ISP, right? And say, hey, I want to connect onto your MPLS network. The ISP is going to say, okay, fine. What internet do you have? And then you're going to say, no, I don't have any internet. They'll say, okay, fine. What area do you live in, right? We have fiber that is connected in multiple areas, or we've got ADSL connections that are in multiple areas. So let's say this ISP has got a point of presence about, let's say, 1 kilometer away from the office. One of two options: either they're going to put a wireless, point-to-point connection that is going to connect this office to their last point of presence, or you're going to dig 1 kilometer of fiber cable so that you can then connect onto their point of presence, which then takes you onto the MPLS network. So that is a physical connection. Whilst the MPLS side seems more logical, the underlying part in every technology is that you are going to need the physical part. There is no way your internet is going to connect onto the provider's network without any physical connectivity that is basically involved. Similarly, inside the MPLS WAN, the routers that are in there are going to be connected physically, and that's what forms the backbone of the MPLS network. So I hope that basically answers your question. If I haven't answered your question in a way that you feel comfortable, please don't hesitate to get in touch, and I'll be able to give it a second attempt and hopefully be able to give you the answer that you need. It is important that I give clarity to the questions that you guys have. All right, so we're going to proceed. And we are going to talk about a very important concept. And I've been debating the best way that I can, put this across or lay this out in a way that we can understand. And I'm going to use this example. Might not be appropriate, but anyway. most of us, oh, sorry, let me just come back. I don't know whether I can say most of us, but yeah, I'm sure this company is not foreign to many of us, right? Tinder has become, one of the most predominant applications that is used in the market today. And probably wondering, what does Tinder have to do with Network Plus? But once upon a time, when people were dating or looking for partners, you'd walk in the street, stop someone and say, hey, I like you. Can I have your phone number? But things have changed. Things have gone into the virtual environment, right? Nowadays, you have to swipe left, swipe right in order to find someone. And that is in what is known as a virtual space. Once upon a time, we used to have servers for everything, right? And servers were basically operating in silos. So you used to have an email server, and that email server was a separate individual box. And then you had another box for DNS, you had another box for DHCP. And these basically made up 3 servers. And most of the times, the email server maybe would run at about 60% of its utilization because emails are quite intensive in terms of capacity. However, DNS and DHCP are not as intensive, so they'll probably be running at 2% and 1%. So in total, you had 300%, if ever there's a percentage like that, capacity, but you're only using about 65% of that total capacity of your systems. And that was underutilization. And that created a problem because obviously you can't keep on adding more servers. As you build data centers, they will end up heating up because there's so much infrastructure that is basically sitting there. So they then came up with a concept known as virtualization. And in the virtualization concept, what happened is that you had one server, and this server had, quite a significant amount of resources. And then inside that server, you then create multiple virtual servers that are running off one single infrastructure, right? So coming back to which allowed multiple systems to coexist under this one particular server. And the way that they achieved that, they used something known as a hypervisor. And what a hypervisor basically does is it abstracts I'm trying to find the right way to be able to explain it. What the hypervisor does is that it sits between the virtual environment and the physical hardware. And it abstracts the physical layer and makes these servers that are sitting on top of it believe that they are talking to the physical infrastructure. And because of that, it then allows you to then put multiple servers in one particular environment. And this has basically grown to become the defining factor of IT. The 2 common hypervisors is one from VMware that is known as ESXi. You probably heard about it. The other one is from Microsoft, and it is called Hyper-V. So the name had come out. I haven't used Hyper-V in a very long time. So Hyper-V and ESXi are the 2 hypervisors that are predominant in the market today. One of them is known as a bare metal hypervisor, which basically means that you install it on a server and then everything else builds on top of that. And Hyper-V, you have to install the Windows Server operating system and then Hyper-V on top of that. So those are the 2 predominant hypervisors. The focal point of this class is not necessarily much to go through the technology of, Hyper-V or ESXi, but you need to have an understanding. When you talk about virtual concepts, you need to know what a virtual server is. That's the first part. The second part is, in order to achieve this one gigantic server, internal to it, it will have something known as a virtual switch. right? And these are the switches that then connected the devices that are internal to the virtualized environment. And then the virtual switches, let me just draw this so that it's probably clear. Right, so what I'm trying to say is this is the big virtualized environment. So this is our virtual environment. And then inside, we've got server 1, server 2, server 3. So 1, 2, 3. And then you've got a virtual switch inside the virtual environment. And these servers then connect to the virtual switch. And then the virtual switch then connects to a network card that goes to the external environment, which is the physical network card, which then connects to the switch on your particular network. So this is known as a vSwitch because it's not a physical switch, it's a virtual switch inside the virtual environment, allowing you to then connect your devices. And that's a very important concept when you start looking at things like VMware. For those that are interested, it's a growing industry. Virtualization has probably taken over. It hasn't stopped on servers. Once again, we used to have physical routers. They're still available. They're still functional, but routing capabilities have now been virtualized. So you can find virtual routers, and this is usually predominant when you're dealing with cloud environments such as AWS and Azure. You put routers in the cloud that are basically running on software, and firewalls as well are now virtualized. So virtualization has basically taken over the industry. And if there's one skill set that I would actually encourage you to learn beyond networking is virtualization, because it is going to affect your day-to-day life. There is no organization that you can walk into now that will not have some form of virtualization that they're basically running on. So very important. Very important technology to learn and understand, and test it and run it through. I just want to trying to show you. Let me just let me just try and pull out my virtual environment so that I can just show you how crucial virtualization is, and how I have multiple servers that I have virtualized. And this is basically on my laptop. So what it basically means is that wherever I go, I can carry my virtual environment. See, I'll just put that on the screen. All right, so this is my virtual environment. And as you can see, I've got JNS3, I've got Windows 2016 server. I have, Linux, I've got AD, I've got firewalls, I've got CUCM on the wireless side. And all this is virtualized. And I can run all these servers, get them talking, get everything else configured, right? So it doesn't take much for you to bring up your own virtual environment, and you can then practice and be able to then utilize that. All right, so we have stayed along on virtualization. Let us look at the different technologies that allow us to connect into the wide area network, right? We spoke about the wide area network, and we said that's the network that takes us to the internet. And there are multiple ways that we can connect to it. We can connect via satellite, and this basically is utilized by people that are in remote locations where there's no fiber cable or telephone cable that have been dug to go into the farm properties or rural locations because of their distance. And how satellites basically work is you've got, let's see, okay, yeah. So you've got these satellites that are sitting, in orbit, and your packets basically go all the way, and the distances can be far, man. Sometimes you're looking at about 23,000, kilometers going up and going down. And because of that reason, satellite links are slow because they suffer from what is known as latency, which is the time that it takes you to go up and come down. that time frame is too long. And I'm sure many of you have heard about Starlink, which is the Elon Musk company, where he's trying to bring fast internet to rural locations. And what he's been doing is he's been putting satellites that orbit closer to Earth so that packets don't have to go all the way up. They can just go a short distance up and a short distance down. So satellite is one of the technologies that allow you to take your home onto the internet. The other one is what is known as DSL or ADSL. And this technology uses telephone lines. So what they managed to figure out was they could pass data on the telephone lines. Many of us had telephones in our houses. So you then plug in your telephone into your computer, and then you got internet connectivity. I'm sure for many of you, you probably might not have encountered this, but back in the day, we used to have what is known as a modem, where you'd connect your telephone line onto the modem and then you use it for internet. However, when the modem was connected to internet, you could not get telephone calls. But with ADSL and DSL, you've got the capability of being able to split the two and run the traffic that is coming through. So your house connection will connect to something known as the exchange, right? There are different names that they call it. They either call it an exchange that is in your neighborhood, or they call it a DASLAM, where you go in and then this is where everyone else kind of plugs into, and then the provider side picks the traffic from there and then flows it into their own ISP environment and then take you out to the internet. And the difference between DSL and ADSL is one is asynchronous, and asynchronous basically means that the upload speed and the download speed don't have to be symmetrical, right? They're not the same. So for many internet services, the download speed is faster. So that could be 50 Mbps, and then the upload speed would be 10 Mbps. Right, but in big organizations, you might want to have upload and download speeds being equal, because people upload many files to platforms such as OneDrive, sending email. So you want to make sure that your speeds are consistent across board. This one is found predominantly in America. You have the cable network. And the cable network was basically primarily a video network, right? That sent, if you're in Africa, that's probably the equivalent of DSTV, where you would watch, movies and things along the lines. You get TV programs, but they also realized that they could push data on such infrastructure, and then they utilize that. So when you're dealing with cable, you're dealing with coaxial cable, and you are connecting to the WAN. So just bear in mind that the different technologies, their whole objective is just to take your either home network or your office network and connect it to the greater network of what is called the internet, so that you can then be able to then traverse and go anywhere that you want. And understanding the technology that is either used at home or used in the office is important for you to be able to then troubleshoot and work out not only how to fix it, but the most important part is the limitations in terms of speed on what each service can be able to give you. Because some services are using telephone lines, they've got limitations on how much data can be able to then flow through as you communicate. So the primary reason for us going through this is so that we have an understanding on the different types of services that you then need to require in order to get connectivity onto the internet. And then the next one is the different cable types. So now we are transitioning onto our local area network, we're now trying to say, when you're in the LAN, how does the LAN function? What are the components that are required in a local area network? What are the different cable standards that are available? What can you achieve with those cable standards? What do they do? What do they not do? And I think for many of us, we have learned about UTP, which is the popular network cable that is used in corporate environments. And what UTP is basically is it's a type of network cable that is used to connect computers, and mainly computers, right? So you will have a switch, and then you have a PC sitting here, and then you've got a server that is sitting here. You connect them via the cable. That cable goes into the port on the switch. That cable, 90% of the times, is a UTP cable. So what does UTP stand for? UTP is basically an unshielded twisted pair. This is the standard type of cable that is used for connecting computers, which falls under the Ethernet standards, right? So Ethernet standards basically define the technologies that are used to connect devices in a LAN environment and what are the properties that are basically involved. So many of us have heard about the Cat5 cable. Before the Cat5, there was probably Cat3 was probably one of the primary entry-level cables that you would find in this UTP space. And what that UTP basically stands for is, as you can see the cable, it is twisted. And that cable is twisted basically to shield the cable from what is known as electromagnetic interference. So they realize that when they twist the cable, it basically protects the cable, and the signals that are being carried over the cable are not degraded or basically affected. So they twisted the cable and they put a shielding on it. And that shielding then protects the cable as it basically traverses through. So why do we have category 5, category 6, category 7? The reason being that as the categories progressed, they were able to carry faster, they were capable of faster speeds and much greater resistance to electromagnetic interference. And so with the Cat5 cable, as you can see, it's made out of 8 wires. And these wires are basically paired. I've done a video on how to patch a UTP cable. I'll probably link somewhere in the description below. Go and have a look at that video so that you can have an understanding. This is actually one aspect or one field of networking that I always encourage people. You need to master this because you deal with this on a day-to-day basis. Doesn't matter how many years you've been in the industry, you're always going to be dealing with some form of cabling at some particular point. So the UTP cable was basically shielded and had 8 wires. So that was Cat5. And Cat5 was capable of 100 meters in terms of distance. So the length that a UTP cable can run on a Cat5 is 100 meters. Now that is important information because I don't know how many times I've been into environments where people run UTP beyond 100 meters, and sometimes you got a network connection that's about 110 meters. And the challenge with that is that your network starts performing in unpredictable ways, right? Sometimes something's working, sometimes things just stop working and you got flapping. And then when you then do the measurement, you then realize that this cable exceeds the limitations of the 100 meters distance of UTP cabling. So whenever you're dealing with UTP cabling, just know that the maximum distance you can go is 100 meters. Don't push the boundary because you're going to have issues with your particular network. And then when Cat6 came through, you notice that there is this plastic coating that was added onto the cable, and that plastic coating gave the cable resistance capabilities to EMI, but above all, it also had the capability of being able to transmit. I think with Cat5, you're looking at 1 gig capability, and Cat6 has the ability of going up to 10 gigabits per second. And that's the second aspect why it is important to know the capability of your cabling, because if you were brought in to install cabling in a building and you're trying to future-proof that network, if you run Cat5 cabling, what you've basically done is that network is going to have a limitation of 1 gig, and it can't go beyond that because Cat5 cables cannot go beyond 1 gig. So when you got servers that are running 10 gig network cards, you don't have the ability to then migrate. So it's very important for you to have an understanding of the cabling limitations and what the cable is able to do. And then Cat7 and Cat8 then basically take you to the 40 gig capacity. I think in the next slide, we'll probably cover those distances in more greater detail. I think the part that I wanted to cover more on this slide is this concept of straight through. So of the UTP cables, you got 2 types of cables. You have what is known as straight through or crossover. A straight through cable is used to connect devices that are not similar. So when you're connecting a laptop, your PC onto a switch, you use a straight through cable. But when you're connecting like to like devices, so if you're connecting 2 pieces together without a switch, you use what is known as a crossover cable. Or when you're connecting 2 switches that are a distance apart, you then use a crossover cable. So just know that there are 2 types. And why it's important is because when you connect a crossover cable, when you're supposed to use a straight through, it won't work. With most of the switches that have been built recently, they have the capability of being able to detect and be able to use either or. But with switches that don't have that capacity, if you're wondering why your network cable is not working, there's probably a high chance that it's either a crossover cable that's connected in a situation where you're supposed to use a normal UTP cable. So that's the part that I wanted to just cover in that regard for you to be able to know. So what type of connectors do you connect to a UTP cable? There are 2 types of connectors, RJ45, which is what we use RJ45, which is what we use on our networks, and then RJ11 is what is used for telephone lines. And when you are connecting your cables onto the RJ45, let me just get that. Right, so when you're connecting your cables onto your RJ45, you push all the 8 cables, they go in, and then you use a croning tool, which basically punches down, it's either called a croning tool or a punch down tool, which punches down the cables into the connector, and then they have connectivity. The 2 types of standards that you use are what are known as the EIA 560A or 568B. And this basically defines the color coding that you're going to use when you connect your cables into your RJ45 connector. The one thing that you need to know is if you're going to be using the B standard is the most commonly used standard. If you're going to be using the B standard, make sure that your cable is a B on both sides. And this is something that usually happens on cables that you manufacture by yourself, is because if you don't pair the cables correctly and one side is A, one side is B, the cable usually becomes a crossover. And when you try and connect endpoint devices, they might not work for this particular reason. I have not been able to master this diagram, and so every time I'm making cables, I have to always go back and reference. There is no penalty, but what you might be asked in the exam is the 2 standards of the 568B and A when you're connecting your network cables. All right, let me just check if there have been any questions. Let me check if there have been any questions, and if you are finding value from this please just hit the like button or just put a comment, or, just whatever, just type something in the comment section so that I know that, we're together and I'm not losing you somewhere in the process. Right, so there's a question. Does the yellow box in the middle represent a switch or a router? That is correct. The yellow box in the middle on the slide that I was looking at is what is signifying a switch. Let me just try and go back and just try and see if I can find. Yes, so this yellow box is what he's asking. So this, oh man, let me just go back, get that. And then I get my pen. Yes. So this yellow box is signifying a switch. That's the best that I could be able to get to depict that particular question. A router, however, I'm always going to identify a router by using either a circle with arrows inside, but it's not going to, when I reference to a square with arrows, I'm basically signifying a switch, but a circle is going to be a router. So yes, that is correct. That he is identifying the switch. All right, let me just check one more time. If there are any questions, just let me know. All right, let's proceed. So you spoke about the connectors. Now, I mentioned earlier on that the limitation of UTP cable was the fact that the maximum distance that you could run UTP is 100 meters. And there are times when you want to run more than 100 meters and connect your devices. I mentioned about a campus area network. And in a campus area network, you've got multiple buildings that are spread around, this one perimeter campus. And you want to connect these buildings to the network. And most of the times, the distances are sometimes, 500 meters, 200 meters to get to the other side of the network. Now, there are multiple ways that you can achieve the connection. So for the 200-meter one, you could put something known as a repeater in between the two offices. And what a repeater basically does is that it basically boosts the signal and gives it the oomph to make it to the other end. But you can't put repeaters in every environment, right? Because sometimes there is nothing but bare ground between these two locations. And repeaters are going to need some form of power of some sort. You also need to protect them from weather. So then it's not practical to use repeaters. And this is when fiber comes into play, because fiber cables have the capability of going longer distances of up to, fiber can go as long as 40 kilometers of fiber. So it allows you to then take your network and extend it to much greater distances that you could not achieve with UTP. So how does fiber operate? There are two types. There's what is known as multi-mode, right? For fiber uses light. Light is shone down the fiberglass cladding, and then that light basically projects all the way to the other end, and the data is then carried over that particular light. With multi-mode fiber, the core of the glass is much more thicker. So when light is then shown, it goes and bounces, up and down as it goes out, getting to its particular location. And by virtue of that, it's called multi-mode because you can shine multiple light rays into that particular fiber cladding, and you can carry different signals as they basically go through. So that's why it's called multi-mode. And because of that, the cladding, which is this opening, is going to be much more wider to accommodate the more signals to be shown through that particular glass cladding. And because of that particular reason, the multi-mode fiber cables cannot go very long distances because they suffer from the loss of packets or the loss of signal as distances then grow and become longer. The second type is what is known as a single mode fiber. And single mode, basically, you got one single light that gets shone through. The cladding is very small. It can only fit one source of light. And that light strand is then sent through all the way to make it to the other side. You might have boosters that stand in the path, especially if you're going much longer distances. But these are the two concepts of how fiber works. So the two types of fiber cables that you're going to encounter in the work environment are going to be single mode fiber, which is denoted by the yellow cable, and multi-mode fiber, which is the first one that we looked at. So you will have single mode or multi-mode. That is going to determine the distances that you can basically run. If you have ever worked in an environment, I'll just try and see if I can get change the color of my pen. No, it's fine. If you've ever worked in an environment where you got campus locations that need connectivity, 90% of the time you're going to be running yellow cables connecting the two buildings. And those yellow cables are going to be single mode fiber. The lighter blue cables, that's your multi-mode fiber. Most of the times, this is used to connect switches, right? So you'll have your GBIC or SFPs, and then you run your multi-mode fiber to then connect your switches so that you got gigabit capability between your uplinks. So when you're dealing with uplinks, you're probably going to be dealing, when the distance is shorter, multi-mode, but most of the time you're going to be dealing with single mode. And I can't stress this enough because you are definitely going to be dealing with fiber. If you're going to work in a network space, you're going to be dealing with fiber cables. Either you're going to be asked to buy fiber cables or you're going to be asked to install fiber cables. So that is basically the differences between the multi-mode and the single mode. Now, the fiber cable has different connectors. You have what is known as the ST, which is used with multi-mode fiber. And this is the ST. This is the ST connector, though I haven't really encountered these quite extensively. The two most common fiber connectors that you're going to find in the environment, this is the old one, which is known as the FC, and this is LC and SC. These are the two most common fiber connectors that you're going to find in the environment. Either you're going to find cables that are SC to SC, or you're going to find cables that are LC to SC. And they will determine, whether you're connecting to a fiber patch panel, which is known as a floorboard, or either a fob, right? So you'll have one connector that goes through here, and then this one then goes into your switch. And then in the back end, you'll have the longer fiber cable that's basically running through. So these are the types of topologies that you're going to encounter in a corporate environment. So getting the right cables is very important. I don't know how many times I've been bent by not making sure that you got the right type of cables. And then when you now want to, run the cables, you realize you don't have the correct types of connectors and you're not able to do what it is that you wanted to do. So it is very important for you to understand the different types of connectors and what they basically do. And we'll look at the distances, right? So this is where we look at the distances of the different Ethernet standards and how long the cable can run, what type of cable falls under that Ethernet standard, what is the speed of the cable, and what is the distance that is basically involved. So not much covered in this particular course, but there's what is known as the IEEE standard of what is defined when you're dealing with Ethernet technologies. And Ethernet technologies basically focus on the connectivity of network devices on a local area network. So it covers things such as your UTP cabling, your fiber cabling, your wireless network standards that allow for that particular connectivity. So it's just basically a regulatory framework that then gives you the capabilities of cables and what they're able to do. So in this table, I just broke down from what is the standard. You probably heard terms such as 10 base T, 10 base TX, 10 base 5. We're basically going to explain in detail what that basically means and what that means to you when you're trying to kind of get an understanding of what cabling you're basically dealing with. Because sometimes all you need to know is it's 10 base T, 100 base FX, 100 base T. This important probably going to come into the exam. So it's a very important concept to master. I have not covered all the standards, but I've just covered what are probably the most common ones. So we'll start with 10 base 5. And this was probably one of the primary technologies that was used during the days of bus topologies. Remember, I spoke about the bus cable that ran through the entire network, and then people would clip onto that bus, and you'd use a T connector to connect to the network. That network was known as 10 base 5. And it was known as the IEEE 802.3, right? So that was one of the first Ethernet standards that were adopted in the networking world. It used a cable that was known as a coaxial cable. And I'm sure many of us have seen the coaxial cable. This is the cable that you use to connect to the back of your TV, either going to your satellite TV service provider, or sometimes going to your socket onto the wall that then takes you to your TV aerial to then give you, the cable looks something of such a nature, and it's got a connector that is round. The cable grade was known as an RG8, and the maximum speed of a 10 base 5 network was 10 megabits per second. And the maximum distance you could run was 500 meters, right? So that basically then gives you the understanding that whenever you encounter a 10 base 5 network, these are the physical properties and limitations of that particular technology. So knowing this then helps you to design networks in a way that is more appropriate based on what it is that you want to achieve for the organization. The next was 10 base T, which was the transition from coaxial cable to UTP cabling, and it was known as the 802.3i. And once again, ran 10 megabits per second with the maximum distance of 500 meters, because UTP cable suffers from EMI and also something known as attenuation, which is basically the degradation of the signal as it goes for a longer distance. So the maximum that it can go is 100 meters. That was then superseded by the 100 base TX, and that could then, it was using, Cat5 running at 100 megabits per second. Point of correction, I think I mentioned earlier on that Cat5 was capable of 1 gig. Cat5 cables are 100 Mbps. So if you're running Cat5 100 Mbps, Cat5e is the one that is capable of 1 gig transmission speeds. The distance is not going to change, it's 100 meters. And then we cross over onto the 100 base FX. Now, this is where you're now talking fiber realms. And you have multi-mode or single mode fiber. the capacity is 100 megabits per second, but now the difference is the distance that you can basically be able to run. With multi-mode, you can go up to 2 kilometers, but with single mode, you could go up to 10 kilometers. So if you had a need in your campus that spanned more than 5 kilometers and you wanted to connect the two buildings, you can then use single mode on 100 base FX to be able to then achieve that. And then on the higher end, you got the 10 gig base SR. So the 10 or the 100 number defines the transmission speed. So when you say 10 base, the 10 is the megabits per second. When you say 10 gig, 10 is the 10 gig capacity of that particular technology. When you say 100 base, 100 is the maximum speed. So if you're not so sure what 100 or 10 is standing for, it's basically defining your transmission speed. And then the base is just highlighting the baseband technology that the cable uses to be able to then push signal going through. And then the letter is used to indicate the media that is used. So we say 10 base T. So when you see T, it's saying that the technology uses UTP cabling. And when you see F, the technology uses fiber, right? It's with the exception of 10 base 5, which probably is not 10 base C, highlighting that the cable uses coaxial. So if you're trying to understand what does 10 base or 100 base, you're basically then referencing. So if you look at 10G base SR, what you're simply saying, the 10 is the 10 gig. And interesting. Also, this uses fiber, 10 gig capacity, and then the distances that you can go is about 40 kilometers. So fiber then gives you the distance, which basically takes us to the next important aspect of fiber, where we deal with something known as the transceiver. And I want us to focus on this part. Let me just get my screen. Okay, right, focus on this part. So this is a port that you find on a switch, which allows us to connect something known as an SFP, or in other terms, it's called a GBIC card. And this GBIC card then allows us to then connect. So our fiber cable will connect to the SFP, and then we connect the SFP into the transceiver that is on our network switch. So an SFP is just basically a hot swappable transceiver that is used for both communication of applications and telecommunication. The transceivers are basically designed to support gigabit Ethernet, fiber channels, and other communication standards. So this is not only limited to fiber. You would have some SFPs that are Ethernet standards. And the reason why you've got these transceivers that are universal is to allow your switch the flexibility of being able to use either Ethernet or fiber. So if this was in the data center, I could be using all these as fiber channels to either connect to my storage and have gigabit capability on my particular network. If I wanted to connect endpoints, or not necessarily endpoints, but sometimes I might be connecting servers that only have RJ45 capability, and that is only an Ethernet standard, I would then use an Ethernet or a gigabit Ethernet SFP to allow me connectivity onto the particular network. So the switch gives you the ability to make a choice on what standard you want to use for the cabling that you want to have on your particular network, but that is basically open to you. So this very important concept. So SFPs were the start. SFPs have different speed limitations. Some can only go up to 1 gigabit per second. And then after SFPs, because of the 1 gigabit per second limitation, they came up with SFP Plus, which allows you to go up to 10 gig. And then now they have the Q SFP Plus, which allows you to go up to 40 gigabits per second capability. So depending on what it is that you're looking for, SFPs, either SFP Plus, SFP, or QSFP, will allow you to then achieve the objective of what it is that you want. These devices are very expensive. So when you do encounter them, treat them with care. Very easy to get lost and very expensive. Unfortunately, I don't have one with me. I probably will buy one online and then I'll probably share it, the next time. But yes, you got different types of SFPs that are available on the market today. Right, and as we are about to close today's class, so if you have any questions that you want me to answer, put them in the chat if you are watching live. If you are going to watch this after the recording, then just send the questions to the email in the description. So now, just to wrap what we have basically covered, today, we looked at the different technologies that we utilize when we are connecting our devices to the network. We say that when you're getting onto the WAN network, there are different, WAN technologies that we can use: ADSL, cable, satellite. We went to look at the different cabling standards. And now we want to look at cable management, right? So you've been hired as a network technician for an organization, and this organization has 500 users in the business, and they have maybe an 8-story building, and it is your responsibility to manage that particular network. So the first thing that you're going to need to understand is something known as an IDF and MDF. And MDF is the main distribution cabinet. When you say main distribution cabinet, this is where your cabling, your cables terminate in the back end. And this is where your switches will be connected. And usually in the main distribution rack, you then have your internet service providers coming into that particular building, right? So your ADSL, right, let's just get back a little bit. Right, so you'll have your ADSL coming here, or your fiber, depending on which provider you're using. If you're in Australia, you're going to be looking at something like Optus or Telstra or TPG, Vocus. If anyone is watching this from Australia and you belong to any of these, please, I'm not being paid. These are the most common ones. So you'll have all your ISPs coming into your MDF. And so that's one side of the MDF, right? So externally, you got all your NTUs. They come and terminate into the MDF. And then on the other end of the building, all of your cables will come and terminate onto the MDF. And on each floor, or 1 in 2 floors, you will have something known as an IDF. And for some reason, the I in IDF has come out of my mind. When I remember, I'll let you know. But then an IDF is where you will have the cables of each floor basically terminating onto the IDF. So I'm going to try and draw this to try and make a point. So on the right-hand side, you've got this, right? So this is the patch panel. This is where, all the cables from the offices, they come into this patch panel, and every floor, or every 1 in 2 floors, will have one of these IDFs. And then that IDF will then connect to a switch. And remember earlier on, we spoke about the 3-tiered system or the collapsed core. So we will have your access switches that will be in each floor or one in every 2 floors in the IDF. So you put your access switches in the IDF, and then you'll have your core switch sitting in the MDF. So this is your core switch. And then maybe you'll have a distribution switch depending on which topology you're using. So all these switches, right, that are coming from the different floors will have uplinks that are coming to the distribution switch. And then the distribution switch will then connect to the core switch. So that's how you would design, or that's how you'd find most of the organizations that have MDFs and IDFs having cabling running in their organizations. And this is a very important concept because with time you will understand, not every organization has tidy cabling, as you can see, on this particular diagram. Professionally, you need to have patch panels. The patch panels will have cables, and these cables are the ones that connect to your switch. And at the back of the patch panel, the cable would go into the office, and there'll be something known as a junction box that the cable connects at the back, and then from the front of that junction box, you'll have a PC that then connects to that. So it's very important for you to understand cable management and how that basically impacts you. This is your bread and butter if you're working as a network technician, and this is where you spend most of your time, looking at. You'll have things like, you'll have a user who's sitting on a desk and the port is not patched to the network. And what that basically means is that there is no connectivity between the patch panel and the switch in question. So you have to then work out this port in the office. Where does it go in the patch panel? What number does it belong? Sometimes the numbers would correspond on the front. So this 1013 would be also labeled on the front part of the port that is in the office. So it's easy for you to then come and trace. In the event that that is not labeled as I basically highlighted, then it's your responsibility to find that and be able to patch. There are other tools that you can use to help you to do that particular process. But I would say 60% of your work, especially if you are a network technician, is probably going to be anchored around about this particular aspect. You're going to be dealing with this on a day-to-day basis. I mean, I've been in the industry for 20 plus years, but I still get those odd calls where, a port needs to be patched and someone has to go and do the work and get that connected. And there is so much fun that can happen here. It might seem simple. If your network is documented and straightforward, fantastic. You can go to your network documentation, and we're going to cover documentation later on. That's one of my most favorite topics, and that's the reason why you need to document, because if you don't document, this can be a nightmare. Because imagine trying to trace a patch panel that's got about 120 plus odd cables running into it, and there's no documentation and there's no labels. Wish you the best in trying to find the port in that instance. There are tools that you can use. The tone generator. We're probably going to cover tone generators later on to be able to help you to do that particular task. If you're rich enough and you've got an organization that has a Fluke tool, then you can use a Fluke device. Unfortunately, I just didn't put a Fluke device in any of these slides, but you'll be able to use one of those devices to be able to then help you. So cable management is very important. And at the back of the patch panel, you will have something like this. Maybe this is a bit more exaggerated because you're not going to have your UTP cables that long, but you would have the UTP cables that are punched at the back of your patch panel, and you use a punch down tool. Yes, use a punch down tool. Let me just, give me a minute. Let me just look into my drawers. Let me see if I can just pull out what you're likely going to see at the back of the patch panel. Right, there we go. I have one of these. I'm just going to put that on the screen. I hope you can see it. So if you look closely, you'll see that there are colors at the back. You got your white, orange, green. So you use a punch down tool, you punch your fiber cable, UTP cable, Cat5, Cat6, Cat7, Cat8, and then this goes onto the wall. And then on the front, on the user's desk, they'll see something like this. And this way they plug in the network cable, and then you got that connectivity. And at the back of the MDF or IDF, you'll have more of these, and you got your cables coming in. So this will be the back part of the patch panel. So very important to spend time, and not much questions are probably going to come in the exam in regards to this particular section. I'm not saying don't study about it. I'm not saying don't read about it, but not so many questions are going to come as a result of that. And then we're going to close. Let me just erase. There we go. We're going to close off our lesson by looking at media converters. And media converters, as the term basically says, a media converter converts from one standard technology to another. And in our case, the media converter is converting between UTP and fiber. Those are the two predominant media converters that you're going to encounter in the industry. So where and why would you use media converters? Remember, early on we said we are trying to connect two campus office locations that are a distance apart from each other, and that distance maybe exceeds 2 kilometers. We can't use UTP cables because UTP cable has got a limitation of 100 meters. Now we're going to look at a very practical in scenario. We've got a server that is, so the distance between the server and the PC is 2 kilometers. And the server has got fiber capability. So you can connect via fiber, but the PC can only connect via UTP on RJ45. So what we'll then do is we'll connect the fiber to the server or to the storage, whatever it is that we're connecting to. We'll run the fiber cable over a 2 kilometer distance because fiber has got the capability to go more than 2 kilometers. And then we'll then connect a media converter, which converts our fiber into UTP. And then we run our cable at 50 meters from the fiber converter onto our laptop, which is using RJ45. And that way, we have bridged a UTP network onto a fiber to connect to the server. So you will encounter quite a lot of media converters that in the industry for that one simple reason that sometimes you've got distance is one of them. The other one is you are trying to bridge a UTP connection onto a fiber link and connect it onto the switch. All right, so you might not be connecting direct to the PC, but you might be connecting onto a switch. So that will then allow you to be able to then, bridge between the two. I've encountered media converters in almost every job that I've worked. I'm not a great fan of media converters myself, and I will explain my reasons. The issue that I have with media converters is that when you place them, you tend to forget that they exist until the day they stop working. And depending on whether you know where the location of the media converter is, because remember, the media converter can be anywhere, right? Where you can just put power and power them. And I've been burnt a few times, where the media converter stops working. They're pretty fragile devices. So a media converter stops working. Number one, you don't know where it is. Or number two, if you manage to locate where it is, you don't have a replacement media converter to be able to replace it with. So now the network stops working halfway, some 2 kilometers between where you want to go and where you're coming from. So that's the issue that I have with media converters. Personally, I try and avoid them at all costs and just have network cables that are running straight into the switches, and not have media converters as single point of failures. At least if the fiber cable is running onto the switch, I can run 2 fiber cables connecting to the same switch, and I can create something known as a port channel, which we're going to look at a later stage. And that then gives me redundancy compared to be running one fiber cable that's going through a media converter, which for whatever reason, due to electricity voltage fluctuations, the media converter can just wake up no longer working. So this is what a media converter looks like. And as you can see, these are the fiber ports, and this will be the RJ45 for the UTP. So you then connect your UTP cable. For those that have basically not encountered them, they're not very expensive. I don't have a scenario where I would encourage you to go and buy it. It's one of those technologies that you're going to encounter on the job and see how it basically functions. Most of the times they'll have spare media converters for you to play around with. But other than that, yeah, I've been burnt a few times with media converters, so I'm very, very, very cautious. If I use them, I don't use them in critical infrastructure because of the fact that they can fail at any given time. And if there's one thing that you don't want in your network is a network that fails in a way that is not predictable, and you cannot be able to control how that network basically fails. So for today, we've basically gotten to the end, but once again we are here, so we can have a chat if there are any other questions. All right, so main distribution frame, that came from Herbert. Thanks, Herbert, for the correction. Yes, I was looking for IDF, right? That's the one that I always forget. I'll probably look for it online, and I probably could put it somewhere in the comments below. So yeah, that's today. We're looking at network fundamentals in the first 3 weeks, just to give us a grounding into what are the concepts that we need, or what are the concepts that we need to learn in order for us to then progress and understand this thing called CompTIA Network Plus. But I know we have two groups of people: those that are studying for the exam, focusing on the certification itself, and then those that are interested in practical skills and being able to learn. I'm more inclined towards the second group, where it is important for you to know the technology, have the hands-on skills, because the number one question that I always get is, I don't have experience, right? I'm looking for experience. And the purpose for this class was to try and focus on how do we go through the hands-on skills. So if you're wondering, but hey, Tinei, we haven't started configuring anything, what's going on? Yes, there's a reason why we haven't started configuring anything. We are still going through the fundamentals. And the fundamentals are understanding things like IEEE standards, the OSI, what is it? What does it do? How does it help you along the way? And at the very onset, it might seem very confusing, might seem not very important or insignificant. But later on, when you go through the network implementation, when you go through the network troubleshooting, maybe just maybe put myself on the screen. All right, so that I can at least communicate much more better. And I'll just take this banner off. And I'm just going to put this one for those that have joined late and you want to know the days and the times are basically on the screen. All right, so I was saying that we might cover things like OSI, IEEE. At the fundamental stage, you might not see the importance of it. But when you start getting into the network implementation, when you start talking about routers and routing protocols such as OSPF, EIGRP, BGP, then the layer 3 component of the OSI or the network layer is going to start making sense, right? In the next lesson, which is on Thursday, we're going to be looking at IP addressing. What is an IP address? What are the different classes of IP addresses? Subnet masks. What is a subnet mask? Subnetting. How do you subnet an IPv4 IP address, IPv6 IP address? How do they differ? What do they look like? Binary, hexadecimal. We're going to be covering all those aspects. And all that touches on the network layer of the OSI. Later on, we're going to be looking at TCP, looking at the TCP protocol, the different ports that you use when you're dealing with TCP and UDP, the different characteristics of TCP, and when things are not working, right? When an application is not performing as per expectation and people are complaining that the application is slow, how do you use TCP to be able to verify that the network is the problem? Because when you work in the networking space, and many of you are probably going to encounter this, right? When anything breaks in the organization, it's always blamed on the network team, right? When applications are slow, network problem. Internet is slow, network problem. How do you defend yourself as a network person to say, no, this is not a network issue, this is an application issue? And understanding of TCP, things like the three-way handshake is very important, because when an application is not responding, it is the three-way handshake that is going to then help you then understand where the issue might be happening. You then look at concepts such as windowing, right? We covered windowing last week. We didn't go much in detail on what windowing was and how it functions and how it works. But that is crucial and that is important. And so this week, we're going to be focusing on fundamentals, because we can't progress if we don't understand the fundamentals. And then next week, we're going to start looking into the implementation. We're going to be looking at layer 2, which is the switching, things like VLANs, things like MAC addresses, things like app cache, and how that functions. All those are layer 2 technologies which operate at the data link layer of the OSI. And then we're going to be looking at binary, which is ones and zeros, and that operates at the physical layer. So what I'm just trying to highlight is I'm trying to map to you the significance of things like the OSI, which might not make sense now, that at a later point, we're going to start looking, okay, so now it makes sense. Oh, this is what it meant, right? When you start looking at troubleshooting, we're going to be looking at the top-down approach and the bottom-up approach, right? When you're troubleshooting, top-down means you start from the top, going down in the OSI framework. Bottom-up, you're starting from the bottom, going up. In simple terms, if a user calls you and says that they can't access the internet, where do you start in your troubleshooting, right? Do you look at the network cable and say, oh, I don't see any lights on your network cable, so the network cable is the problem? So you're starting with the physical layer, which is layer 1. Or do you say, go to google.com and see if you can access the web page, right? By so doing, you're starting from the application layer, which is layer 7. So that's the top-down approach. Or you start from the middle, where you use ICMP or ping to verify if you've got reachability and connectivity. So if you don't understand the OSI layer, it then becomes difficult to know at which layer is ICMP operating on. Is it a layer 3 protocol? Is it a layer 4 protocol? And if it's a layer 4 protocol, is it TCP or is it UDP? What are the characteristics? So all these things are going to start making sense when you get to that particular stage. But I'm excited for the whole experience. I'm excited to share the journey and to share my experience. And if you've got any questions, outside of just Network Plus, as we're going through this particular bootcamp or course, please don't hesitate to ask me. I'm here to answer as many questions as you have in anything relating to networking, and be able to then help. So don't just confine your questions to the subject matter that you're basically be covering. But if you've got any questions, regarding certification, regarding exams, I will be able to, share my 2 cents to the topic and be able to tell you what I think and where the industry is basically going. For those that are wondering why I've chosen Network Plus, is because this is the foundation of networking. You might specialize in Cisco and do CCNA or CCNP, or you might go and do Juniper or Fortinet, whatever path you might take. Everyone passes through the basics of networking. This is the foundation of networking as an industry. And as you know, a house without a strong foundation is not good enough. Why? Because it doesn't have a solid base. So it is important that you have a very good solid base, and Network Plus covers all these technologies and gives you a very, very good perspective. It might not practically cover everything and practically focus on everything, but it's going to give you a very good foundation that then sets you up on to whatever path you're going to choose to take. I don't know how many times I've said it in this course this far that I still deal with cabling on a day-to-day basis. Not maybe on a day-to-day basis, but once every week I have to deal with some cabling setup. I think about a week or two back, I was involved in patching of ports of a new tenant that came on the estate where I work, and I was using cable management skills, So these things, you will encounter them and they will affect you on a day-to-day basis. Not every day that you're going to be sitting on a router or a switch that you're configuring, but sometimes you have to deal with this low-level stuff to get things going. So it is very important. I am excited to look at IP addressing. That's one of my favorite topics. Looking at different types of IP addresses, subnetting, binary, hexadecimal. So I'm really looking forward to our class on Thursday. And if there are no questions, once again, thank you for spending your time, going through this class. And I look forward to, be with you for the next 6 weeks and any other subsequent courses that you might want, me to cover. I'm very interested in sharing information and sharing my journey, because there's no limitation on who you can become. It is what you set yourself to achieve. I've said this in the previous video, and I'll say this again. When I studied Network Plus and A+, we are sharing one textbook, amongst 10 students. We were not learning in a very fancy classroom. It was very basic, probably on the lower end. But we had the passion and the determination and the desire to want to learn. And that's all that mattered, right? It was at a time when internet was not very prevalent, so you couldn't go online and watch videos like this one. You had to get a CD from someone who might have paid $1,000 for a particular course in order for you to learn. But nowadays, information is available, and there's nothing that stops you from learning anything that you want to learn. The only thing that I basically encourage you, which we'll probably talk about later on at the end. I'm sure I'm probably waffling and saying a lot about this because we finished our class, but I'm going to have a dedicated lesson, rather, or probably 30-minute lesson on, planning and setting your goals of where you want to be in the next 12 months, in the next 24 months, in the next 5 years, as you progress in this networking journey, and determining what skills you need in order for you to then achieve those particular goals. So for many of you, you probably want to become a network engineer at some particular point. You might be working in the IT industry, probably not into networking, or you might actually be working in networking at the moment. But if you're not working in networking, then you've got to set yourself a plan to say, in the next 36 months, which is 3 years, I want to be a network administrator. In the first 12 months, I want to be a network technician. And this course is going to be the starting point to take you to network technician level, because then with Network Plus, you'll have the understanding to be able to then go into the industry and get yourself a network technician job. Because when we're done with this particular course, I don't see anything that will stop you from being able to go and, take in that role as a network technician. And if you get stuck, you'll have my email address. Just send me an email. I might give you my number. You can probably give me a call, So at least you have someone that you can talk to if you get stuck at work and you want someone to help you navigate. I also have people that I talk to, so all of us in the industry, we always have someone that we call to be able to help. So yes, first 12 months, network technician, next 24 months, network administrator, and 48 months, which is in 4 years' time, you want to be a network engineer. And along the way, Network Plus is not good enough by itself. You might need to get CCNA, you might need to get CCNP. So planning all that is very important. Yes, Meta, IP addressing is something I can't get my head around. Oh, that's fantastic. That's one of my favorite topics. And I'm going to try and break it down in a way that is simple for many people to understand, because this is one of the very difficult concepts to get your head around. And at the same time, it is a very important concept that affects your day-to-day, because if you're going to be dealing with routing and IP addresses, then subnetting is going to be very important, because when you deal with firewalls, access lists, you're going to be permitting and denying traffic based on particular subnets. And if subnetting is not your core skill, you're either going to deny traffic that you're supposed to permit, or you're going to permit traffic that you're supposed to deny. And in the end, it just, causes chaos. So I'm going to try to be as slow as possible to make sure that the concept is well understood. And then also, I've done a full course on IP addressing, and I'm probably going to put a link in the description later on when I finish this recording. I'm probably going to put a link of that particular course. So you might want to go and watch that one as well. I covered the whole subnetting IP address classes in more detail. We'll probably cover that in this particular class, but yes, if you want additional material that you can go and watch, I've done a full class on that particular subject in question. But once again, we're going to be covering that on Thursday. So Thursday is probably going to be a longer lesson, probably going to take a good 3 hours just to make sure that we have covered IP addressing. And if you've got any questions, please bring them. If you can actually send me the questions in advance, that'd be more than welcome. At least when I come into class, I can be able to make sure that I preempt and answer those questions. But yes, I'm also looking forward to IP addressing because that's one of my favorite topics. I love IP addressing. I don't like IPv6, but once again, it's in the syllabus. We've got to learn it and we have to cover it. So I'll get it done. And yes, if there are no other questions, Edwin, thank you very much. Long time, my friend. It's good to, to know that after a very long time, I've got people that I communicate with that are still able to come online and, go through this course. I'm excited to go through this journey. And once again, guys, my lines are open. Get in touch. Any questions, send me an email. It might be network related, might be this course related, or just, generic advice in as much as the network industry is concerned. I'm here. I'm here to help. I'm here to give the best of advice, based on my encounter and my experience in this particular industry. I have been fortunate enough that I've worked in 2 continents and multiple countries, and I'm willing to share that particular experience with, as we go through this particular lesson and help someone as they go through their own particular journey. So don't hesitate to get in touch. If there are no other questions, thank you very much for your time. And I'm looking forward to Thursday. Yes, I'm looking forward to Thursday when we're going to be looking at IP addressing and the different aspects of IP addressing. All right, so guys, I'll see you. Thank you very much for your time.